Okay, so this example of integration, we're going to use U substitution that we've been working on. And what you're looking for is you're looking for the innermost function. So this is the function. And you're looking for what would be the innermost function, the inside function. If you took cos of 4x, okay, that's not the innermost function. So you want to look deeper inside. And of course, this is cos of 4x. So if you let u equal 4x, this is your innermost function. Okay? So you have two layers. You have the outside layer and you have the inside layer. You want to make u your inside layer. Now, the derivative of u is 4 dx, right? And we don't have a 4 here, but that's no problem. And again, what I would suggest, and it's been, one of you said that we could do this a bit different. I like just going with this spot right here, and you say, this is what I need in order to replace it with du. And so you go over here and you go, hey, I need a 4 dx here to make this U substitution work. And what I do, when I multiply by a 4, I would have to divide by a 4 to just balance that out. So you just put a 4 there, a 1 over 4 outside, and we're good to go. Now, what are we good to go with? What do we do? What do we do next? Well, what we do next is now we substitute, because that's the whole idea here is U substitution. And so you substitute cos of u. And 4 dx is actually du, so cos of u du. It may not look that much simpler, but really here we had two functions, a function within a function. Here we just have one. And if the derivative of u is just 1, so there's no chain rule to be done or to undo. And so this becomes really simple. This and this are going to go away. Why? Because I've got u there and I've got u there. And so all you do is take the antiderivative of cos of u, which is sine of u. Okay? The antiderivative of cos is sine, both positive. And, of course, plus c, right? And what did we almost forget here is that 1/4 we had out here. And so that's 1/4 sine u plus c. Now replace u with 4x. And you should have your answer to the indefinite integral. Make sure you add plus c there. So a quick check. We better check this. Okay, good idea to check it. And what you would do is you take the derivative, right, of this right here to see if it matches up with our original function that we were taking the derivative of. So 1/4 sine of 4x. If I take the derivative of this with respect to x, I get 1/4. The derivative of sine of 4x is cosine of 4x. And I'm going to have to multiply, of course, by the derivative of the inside function times 4. The 4 and the 1/4 cancel out, and you're left with just cos of 4x, which matches up unbelievably well with the original function that was in the integral there. Okay, so here is your answer. Ta-da! So let's do another example. Here is the integral of secant squared 6x plus 1 dx. Oh, now that looks really ugly, doesn't it? Terrible. Not really. Because we have outside function, secant squared of blah, inside function, blah. So, you are going to equal 6x plus 1, whether you like it or not. Du is 6 dx. The derivative of u is 6, no problem. I look over here, and do I have a 6 dx anywhere? No, I just have a dx. I say to myself, it would really be nice if I had a 6 dx, so let's just make one. And of course, if you do that, you got to do this. So we're in really good shape now to integrate. See that? Okay. Sorry, not integrate yet. Substitute. So let's substitute first, then we'll integrate. So we have 1/6. The integral of secant squared u. 6 dx, which becomes just plain old du. Okay. Now I know what you're thinking. How are we that much further ahead, really? It still looks gross to me. Well, really, you only have one function to take the antiderivative of, right? One. Just one. That's the whole point. Whether it's secant squared or tan or cos or 2x squared plus 1 or whatever it is. You can take the antiderivative of one single kind of function. When you have two kinds of functions, that's when it gets a bit messy. Okay? So that's why we're doing U substitution. So what is the antiderivative of secant squared? Tan. Okay, so tan. Is it tan squared or just tan? So tan u. So the integral sign and the du go away. And plus c. So if we replace now, that is 1/6 tan of 6x plus 1 plus c. That's your answer. Check that. Okay, take the derivative of 1/6 tan of 6x plus 1. So the derivative of tan is secant squared. Right? And we had this out there, I guess, already. So take the derivative of this is this. And, of course, we have to multiply by 6. So the 6th and the 1/6 cancel each other out. We have secant squared 6x plus 1. And that is exactly what we had in the original question right here. So you're good to go. Checks out.